Everybody, it's Tyler here at the Michigan State Championships, checking out team number 4362 Gems, who have 2 event wins already under their belt, looking for a big performance here at MSC. And to help me talk more about this robot, I have Keith, Luke, and Kyle. And we're going to be talking more about this robot as we go through, of course, that cargo journey, following all the way up. They have a great traversal climber. We just watched them play in the match too. Interesting type of intake, so focus a little bit more on that. And of course, the rest of this robot coming up here on Behind the Bumpers.
Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register.
Let's start out on your intake. So your team went with more of a kind of a compliant intake, but I really want to talk about the different choice of material on this as well too. Talk to me more about it.
Yeah, so when we were making our intake, we definitely did test around with a lot of different types of wheels, and we came to the conclusion that these compliant wheels were pretty good because they really get the right compression on it. You can see on this side of our intake, we have these vectored 3D printed wheels actually. We ordered them out of, I don't remember, but we ordered them in the 3D printed. They vector the ball this way so that, and when we have a ball stalling here, it can be pushed into our transfer system.
Sure.
In previous matches, we were actually getting a stall, if I can bring this out, we were getting a ball stalled up in this corner right here, and we actually moved this over right here to put this vector wheel here and just help it push this way, same on this side. This 4th bar right here, we actually didn't originally have, and we ended up adding it with the Velcro to just kind of bring the ball in when it's bouncing a little bit, help it in there.
Are you noticing that Velcro's making a bit of a difference too?
Oh yeah. When the ball's bounces a little bit, it really helps it bring it in.
Sure. So it kind of just almost like slaps the balls down and brings it right into your robot?
Yeah, of course.
Very cool. Can we see the cargo come in?
Yeah.
And we'll demonstrate that a little bit more. So on this on here, so your intake, as I mentioned, it's kind of a compliant because it moves a bit, but it actually seems quite sturdy at the same time to me. When you were looking at building your intake, like what was some of the thought process on like how or what type of material you wanted to go with?
Yeah, so we went with this Lexan material with obviously these pneumatic pistons because we wanted to be able to take a hit. And we also wanted to be able to replace it if it did get broken or damaged. And we found that Lexan's just a really good material to have that done. So.
You got quite a bit of belting on your transport area, so both going horizontal and vertical. Just talk to me more about the design for that, and then how did you figure out like what angle you wanted to go to so the cargo wouldn't jam or anything like that too?
Well, the angle wasn't. The angle was basically just linear, but the belts they push it through. The main thing in this is the compression. We were messing around with the right compression for the transfer, and we ended up putting these bars here just to get it right. We have this color sensor right here where it detects what the cargo is, and if we pick up the wrong colored cargo, we actually spin our uptake down and continue this, so it just kind of goes out the back here.
Oh, so it actually comes out the backside here. Can we? Is there a way we can demonstrate that too? I'd love to show that off.
Can you get a blue cargo?
And while that's happening, while you're all grabbing that, when you're looking at from a strategy standpoint on there, where in the priority process was that for your team? Is that like a, hey, we knew this would be an issue, we need to create something like this?
Oh yeah, so in previous competitions, we actually didn't have this. We knew we knew that teams were going to be doing this, but we just didn't think that it was worth the time. And between our last competition in Milford and this competition, we moved our electrical components to the front of the robot here, and it opened up space for us to have this pass-through system.
Well, let's show that off, and we'll see how it ejects out.
There you go.
Oh, so just nice and simple. I was kind of expecting just like a really violent reaction there. So I love that on there. Let's continue going on to your shooter. We'll talk a little bit more what's gone into it. So your team here going with a turret on there. Saw it shoot on there. Looks like you're able to shoot from all over the field as well too. So love to hear a little bit more about shooting preferences as well.
Yeah. So before we have a hood on here right now, but before we had a very small shooting range.
Sure.
So we figured out with the hood, with the adjustable angle, we can almost shoot from anywhere on the field. So that's this red thing here that moves up and down. I don't think I can when it's enabled, but yeah. So we have a limelight right here as well that detects the tape on the hub, and the computer calculates how far away is it to tell the motors how fast to spin, and the angle at which the hood.
So your hood is actually, the angle is actually adjusting based on the feedback from the limelight as well?
Yes.
Very
and
cool.
The driver does nothing to aim. It just presses the button to shoot. The computer limelight does everything.
How do you know when you're in the right spot? Are you getting like feedback on the driver station that says like, hey, I am angled and currently at the right location for that?
Yes, yep.
Very cool. Do you have I know you say you can shoot from all over, but do you have like a sweet spot for gems, like where you prefer to shoot on the field, or does it not matter?
Usually that's right next to the launch pad.
Very
but
cool.
Really, we can shoot anywhere in the tarmac, outside the tarmac, next to the tape. That's really our sweet spot, but yeah.
Let's wind up on this robot. We're going to hand it over to Kyle, who's going to talk more about your climber on here. And Kyle, I'd love to hear not just about what the climber is, but also if we can show a demonstration of the climber as well, too. Maybe narrate a little bit more about it.
Would you like the demonstration first?
Yeah, let's do it.
All right. So we have 2 stages to our climb. It's fully automated. So press 2 buttons, and this is called pre-climb. So now we drive forward into the mid-bar, and then we press another 2 buttons, and we go into our auto climb. And from here, as this angle is backwards, this will raise, but it's not right now.
Yeah.
It's got a sensor.
How long does it take for your team to climb typically?
We have it about 9 seconds.
And when you're looking from a packaging design perspective, so it looks like a lot of it's kind of almost modeled around your climber, right? You got everything coming through the inside of that. How did you go through like the CAD work on that, the model it so it would go that route?
So we actually started like our space design with the climber, because we thought that this was the most important part of this game. So from there, we kind of just allocated the space where it was needed. So this was the first thing we figured out. It's basically how it went. An interesting feature about our climber is right down here, we have constant force springs. We have 2 of them. They're rated at 33 pounds each.
Sure.
And so 66 in total. This reduces about half of the force needed to pull up. So instead of like 10 pounds of force going up and like 125 going down, it's 10 pounds up and 65 going down.
Yeah, it makes it nice and not a lot of wear on your motors, right? Able to just pull up quickly. Love it. So
really
4362 Gems, thanks a lot for taking the time. Tell us about your robot. Wish you best of luck here at MSC. Hoping for a championship berth as well, too. So good luck on that. And can't wait to see your robot through the rest of the competition. Thanks a lot for taking the time.
First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.